Intel's got these new Core Ultra Series 2 processors hitting the market. But you know what? The name is hiding a pretty big secret. See, it's not actually one chip we're talking about. It's two, and they're completely different. One is an absolute AI monster for laptops, and the other, well, let's just say it's a very different story. So let's break this whole confusing situation down and figure out what's really going on. So if you've been looking at this and kind of scratching your head, trust me, you are not alone. The big question is why? Why would Intel put one single name on two chips that are just worlds apart? One's for your big desktop rig, the other's for a thin and light laptop, and their whole design philosophy couldn't be more different. We're gonna uncover the strategy behind this whole thing. All right, first up, let's tackle the chip that's built for high-performance desktop computers. This one goes by the codename Arrow Lake, and how it's put together is actually really fascinating. Okay, so Arrow Lake is built using what's called a chiplet design. The easiest way to think about this is like building with Legos instead of trying to carve a masterpiece from a single solid block of wood. Intel is taking a bunch of smaller, specialized little chips, they call them tiles, and connecting them all together to create one big, powerful processor. This whole modular idea is the key to understanding this chip. Now here's where it gets really interesting. Look at where these little Lego bricks, these chiplets, are actually made. The main brain of the operation, the 3-nanometer compute tile, that's made by TSMC. In fact, you can see the graphics tile, the SoC, the I/O tiles, all TSMC. The only part Intel is making here is the base tile that everything plugs into. I mean, this is a huge deal. It's a multi-foundry chip, which basically means Intel is leaning on its biggest rival to build its flagship desktop processor. That is a wild strategic move. So with all this cutting-edge multi-foundry tech being poured into this chip, you'd probably expect a ton of built-in AI power, right? Well, this is where our story takes its first big unexpected turn. What kind of AI performance did Intel decide to pack into this fancy new desktop chip? Just 13 TOPS. That's it. 13 trillion operations per second coming from its neural processing unit, or NPU. Now, to put that in perspective, TOPS is how we measure AI horsepower. It's what lets a computer run all the cool new AI features right on the machine without having to call out to the cloud. So remember that number, 13 TOPS. Just lock it in your head because it's about to become very important. Okay, time to switch gears completely. Let's talk about the other Series 2 chip, the one that's designed for those super thin and light laptops. This one's called Lunar Lake. And folks, it is a completely different beast. Brace yourself for this one. You remember that 13 TOPS from the desktop chip? Well, the total AI performance of the Lunar Lake platform is 120 TOPS. No, that is not a typo. It's nearly 10 times the AI power, all crammed into a chip for a laptop. So the obvious question is, where on earth is all that extra horsepower coming from? So here's how they do it. It's a total team effort. The GPU's doing the heavy lifting, providing a massive 67 TOPS. The NPU kicks in another 48 TOPS. And let's just pause there. That NPU on its own is almost 4 times more powerful than the entire Arrow Lake NPU. And then the CPU chips in about 5 TOPS. You put it all together, and you've got yourself an on-chip AI powerhouse. The design here is also way more streamlined. Pretty much all the thinking happens on one single 3-nanometer brain tile from TSMC. This thing houses the CPU, the GPU, and that powerful NPU all in one spot. Then there's a separate nervous system tile to handle all the inputs and outputs, and they both sit on an Intel-made foundation tile. The whole point here is integrated, power-efficient performance. Okay, so we've got 2 chips, 1 name, but they have wildly different AI capabilities. So what gives? Well, this wasn't an accident. It's actually a tale of 2 very distinct strategies for 2 very different kinds of people. So why that huge difference in AI power? Well, for the desktop chip, Intel is making a really big bet. They're basically assuming that anyone who's a performance enthusiast, gamers, creators, they're not going to use the graphics built into the chip anyway. They're going to go out and buy a big, powerful separate graphics card from NVIDIA or AMD, and Intel expects that card to do all the heavy lifting for AI tasks. So it really boils down to 2 completely different philosophies. The desktop strategy is all about power via add-ons. It's relying on a separate GPU to handle demanding AI jobs. The laptop strategy, on the other hand, is power via integration. It's all about creating a super efficient all-in-one solution for incredible AI performance when you're on the move. So after breaking all that down, what's the big takeaway here? What does this actually mean for you when you're maybe looking to buy a new computer? Honestly, the most important thing to get from all of this is that the name Core Ultra Series 2 is pretty much just marketing. All it tells you is that it's new. It tells you nothing about what the chip is actually designed to do. To really understand what it can do, you have to look past the name and see what kind of device it's in, a desktop or a laptop. So let's just recap it all one more time. You've got Arrow Lake for desktops, which has a pretty modest NPU because it assumes you're going to bring your own powerful GPU for the serious AI work. Then you have Lunar Lake for laptops, which has massive, fully integrated AI power designed for efficiency on the go. It's 2 chips, 1 name, and 2 completely different roads to performance. And this all leads to a really fascinating question about the future. Intel is betting that desktop users are happy to bring their own AI power to the party. But is that a safe bet long term? As AI gets baked into literally everything, from our operating systems to the simplest apps, will a powerful, integrated AI engine just become a non-negotiable feature for every single computer, whether it's a desktop or a laptop? Definitely something to think about.